In the previous video, we saw how services work in details. In this video, I'll introduce another concept known as ingress. If you want to access an application from outside the cluster, then so far our option has been to use node port. However, the problems with node port is that you still need to know the IP of the nodes to access the service. Also, you cannot load balance between the different nodes, except for what the services do internally using IP tables. Ingress allows you to add a load balancer that provides a single HTTP or HTTPS endpoint for applications hosted in the cluster. The request is routed via Ingress to the services and then to the pods. Ingress provides four functionalities. First, it provides a URL to access an application from outside a cluster. Second, it allows SSL termination. Third, it allows routing to services based on path. And lastly, it provides the capability to route HTTP requests to multiple host names on the same IP address, also known as name-based virtual hosting. There are two key concepts while implementing an ingress: ingress controller and ingress resource. An ingress controller is like the other controllers that we have seen earlier, but the difference is that it is not started by default by the Kube controller manager. You need to install an ingress controller externally. There are many available implementations of Ingress controllers, and in this video we will be using the Nginx controller. An Ingress resource contains the configuration for Ingress and includes rules for which backend service to send the request that it receives. Any request that does not have a rule is sent to a default backend. The Ingress rules are broadly divided into three types. The first is where it provides the rules for a single service. For example, we can write an ingress rule for the static website that we deployed earlier. Any request to the ingress DNS will be forwarded to the static website. The second type is where the request is forwarded to an appropriate service based on a path in the URL. The third type is where the request is forwarded to an appropriate service based on the host name. Let's see the path-based and host-based ingress in action. We have already deployed the static website and the Spring Boot API on the cluster. In case you need to install it again, please use the deployment file from the links shown in the slide. Please pause the video if you need more time. Now that the applications are installed, we will install the ingress for path-based and name-based routing. Let's choose a domain name to access our apps. For this demo, I have chosen www.xmlunit.org. We will change our host file so that domain points to our ingress IP, which is our Minikube IP. In a production cluster, we would need to install the Ingress controller, but luckily for us, Ingress in Minikube is just an add-on. We enable it by typing in minikube.exe add-ons enable ingress. This will install the Ingress controller. The configuration for Ingress is called Ingress rules. We write it in a YAML file. Let's write our first file that will create the path-based routing. We want all requests for www.xmlunit.org/static to be sent to the static website service and xmlunit.org/spring to be sent to the Spring RESTful API. Let's begin writing our YAML file. The first line is the version, the kind is ingress, metadata contains the name and annotations. Nginx Ingress needs the rewrite target annotation when we want to forward the request to root of the service. So for example, even when we type xmlunit.org/static, we want the request to be forwarded to the root of the static website app and not the /static endpoint of the website. Next, we write the specification which contains the rules for ingress. Our rule is applicable for the xmlunit.org host. Within this rule, we forward each port to a particular backend. Note that if a request comes in that does not match any path, the Ingress controller sends it to a default backend. Since we haven't specified a default backend, the controller creates one for us. We write rules so that /static is sent to static website service and /spring is sent to the Spring RESTful API service. The port number is the port on which the service is exposed within the cluster. Our YAML file has been created now. Let's apply the rules. This creates our ingress extension. To see whether the ingress has been created successfully, we type in kubectl get ingress. If the address column is empty for you, wait for a bit since it sometimes takes a couple of minutes for Minikube to populate it. We describe the ingress to see if the rule has been created correctly. We can see the paths and the backends, and it looks good. It's now time to hit the URL and see if it works. We first hit the URL without a path. It has been forwarded to the default backend as we expected. We then hit the static endpoint. The request has been handled by Ingress and forwarded to the static website service. Similarly, when we hit the Spring endpoint, it will be forwarded to the Spring RESTful API service. This is called path-based routing. Another way to route is to use name-based routing. For example, we can forward static.xmlunit.org to the static website service and spring.xmlunit.org to the Spring RESTful API service. Here's the YAML for that. The initial few lines are the same. When we start writing the spec, we will write a rule for each host. We forward static.xmlunit.org to static website service and spring.xmlunit.org to the Spring RESTful API. We apply the YAML and look at how the ingress looks like. It has two hosts now instead of one. The describe command confirms that our routing is correct. We curl both URLs to make sure the routing is correct. Looks good. Ingress works on layer 7 and hence only works for HTTP and HTTPS and not for any other port. This finishes our discussion on Ingress and the section on networking. We haven't talked about load balancers yet since we will need a cloud cluster for that. So far in our applications, we haven't looked at how to store persistent data and start pods whose identity is not lost. In the next section, we will look at volumes and stateful sets. See you in the next video.